What's up? What's up? It's your man Jimmy Chan. All right, so here we have this rational exponent equation that we need to solve, and we got different rational exponents. So there's actually two ways of solving this. So I'm going to show you both ways. The first part though, before I even start anything, is that what we need to realize is that these are actually square root problems, right? This is actually a square root problem because the root is a 2, right? That means these are square root problems. Now, why the heck did I even bring that up? The reason why I bring that up is because we do need to check our answer. That's why I brought that up, okay? So that's the hard part with these rational exponents, is that we need to realize which ones are eventh roots or square roots, fourth roots, and where we need to check our solutions. So in terms of the easiest way of doing this, that's only if you can see this, is that I can do this as like a quadratic equation, or I should say as a factoring form of quadratic equation, meaning I have a GCF here, right? So if I had, let's say, for example, if I had x minus 8x, or x squared minus 8x equals 0, right? I can't get it to a quadratic, so I would just factor out x, leaving it x minus 8 equal to 0, and then I say each one of them equal to 0, right? So essentially this is the same idea. So what I can do is I can pull a GCF out here, and it would be an x to the 1/2. If I pull a GCF of x to the 1/2 out, then what I'll have here is going to be x to the 2/2 minus 8, right? And notice what x, so if you want to check this, you can. So when we multiply x's with the same base, different powers, what do we do with the powers? We add the powers. So I have 1/2 and 2/2. 1 plus 2 is 3, and keep the denominator of 2. So really what we have here is x, let me do it this way, it'd be easier. So what I really have here is pulling out the x to the 1/2 and leaving me with x minus 8 is equal to 0. Okay, so I set each factor equal to 0. So x to the 1/2. I have these tools and I don't use them. X to the 1/2 is equal to 0. And x minus 8 is equal to 0. So I have x is equal to 0 and x is equal to 8. And that would be my answer. So that is the easy way of doing it. Now, what's a harder way of doing it? Well, the harder way of doing it, well, not harder, but more detailed, and it might take you guys this way anyways, because that's the way your brain might think. So one of the things I said in class was to isolate one of the rational exponents, right? So you go, okay, so let's do this. Let's go ahead and send that 8 over to the other side. So I have this is equal to that, because I got to add it over to the other side, right? Then what I will have to do is now I got to get this x by itself, so I'm going to raise this to the 2/3 power, which is the reciprocal power, so I got to raise this side to the 2/3 power, right? And don't forget, this 8 and this x is actually multiplying. So on the left side is nice because I only have x left, so this is going to equal to 8 to the 2/3 times x of 1/2 raised to the 2/3. Okay, right? This is a power rule that we're supposed to remember. So what I really have here is x is equal to 8 to the 2/3 means square 8, 64, take the cube root of it, and then here, when we raise a power to a power, we would be multiplying the powers, right? So what do we have here? We got 2 over 6, which really is going to reduce to 1/3. Okay. So with that being said, how do I want to do this? Got it. So what I can do now is that since this is already here, what I can do is this. I could just raise both sides because, again, I'm just trying to get rid of those fractions, really, right? So what I can do is now cube both sides, because if I cube both sides, what happens is that rational exponent goes away. So again, I have x to the 3rd, but on this side I have 4 raised to the 3rd, and I have this x to the 1/3 also raised to the 3rd. So I probably should make these red and make this red also, so you guys see what's being raised there, right? All right, so now what do I have? Well, now I have x to the 3rd is equal to 64x, right? Because this is going to be opposite operations right here, so that kind of goes away, leaving me with x, and then 4 to the 3rd is 64. So now I can see, ooh, look, I can now do this as a quadratic, meaning bring everything to one side. So I x to the 3rd minus 64x is equal to 0. I have a GCF of x, leaving me at x squared minus 64 is equal to 0. That is the difference of two squares. So that means I'm going to have x equals 0, x equals 8, and x equals negative 8. But then you're going to say to me, but dude, you have two different answers here. You're kind of right. But again, I have to check my solutions, right? So if I was to put in here a 0, the 0 will work, right? Because 0 raised to any power is just going to be 0. 0 raised to any power is 0 times 8 is 0. So I got 0 minus 0. So that works, right? So if I put an 8 in here, let me see. If I cube 8 is a big number and then takes the square root of it, let me see what that comes out to me. Oops, I don't want to square it. I want to square root it. And then 8 and then square root of that. So that is still going to work. All right, trust me on that. But you put negative 8. Can you put negative 8 in here and take the square root of negative 8? Because if you cube it, it's still negative. Then you got to take a square root of it. Now it becomes imaginary. So that's why I would have to reject this. So my result here is still going to come to this. Right? Which, ladies and gentlemen, that is going to be choice C. Well, I hope that helps. If there's any questions, If there's any questions, please let me know. See ya. Bye.